Happy Friday, everybody. I hope that you are having a good day. We are going to talk about writing equations of lines today. That is going to be our topic, and we are going to touch on all of the things we learned in. Sorry, you know me and spelling. I've got to be careful. We are going to touch on everything we learned in Algebra 1 and a few other times we've talked about things. So please write these notes down so that you have a few examples to go by. There are a couple of things. We can be given the slope and the y-intercept. So it's going to depend on what you are given as to all of the steps that you have to follow. If you are given the slope and you're given the y-intercept, all you have to do is plug in. You know that you have y equals mx plus b. And so if I give you a slope, problem number 1, my slope is 2, my y-intercept is 3, then my equation, I'm just going to plug into y equals mx plus b. I keep my y equals, I go over here to get my slope, which is 2. I keep my x, and since it's a positive 3, I'm just going to grab that and write it as y equals 2x plus 3. Another example is if I give you my slope is 0 and my y-intercept is negative 1. I start with y equals mx plus b. I plug in my slope, which is 0, and my y-intercept is negative 1. So some of you might want to write that as minus 1, some of you are going to write it as plus negative 1, but I hope that you're seeing that if you have a 0x, we can clean that up. That's just going to leave us with y equals negative 1. And all of us should remember that if you just have a y, anything in the form of y equals a number, we're talking about I almost wrote the wrong thing. Y equals a number is a horizontal line, and x equals a number is a vertical line. So, our second type of writing a line is if we are given the slope and a point on that line. Now for those of you who had me for Algebra 1, remember we made the 3 flat foldable where the first step was you're given the slope and the y-intercept, and then the second step was a slope and a point. I typically tell everybody that if I have a slope of negative 2 and a y-intercept of 5, all I have to do is plug in. But if I have a slope of negative 2 and then I give you a point, I could give you the point 1 comma 3. So that is a different situation. You can't just plug in. You have your slope to plug in, but what you are missing is your b, or your y-intercept. I need to know my y-intercept. So there are 2 ways that we're going to look at to solve this problem today. One way is to use our y equals mx plus b, and we know that we have our slope right here, m equals negative 2, and our x comma y, we can pull those. So we have 3 equal to negative 2 times 1 plus b. That's what we're looking for. We're looking for that b. And so we have to isolate that variable. I get 3 equals negative 2 plus b. And then I add 2 to both sides, and we get 5 equals b. So I find out that my y-intercept is 5, my slope is negative 2, and so the equation of my line is just going to be y equals negative 2x plus 5. You have to use y equals mx plus b in order to find your y-intercept. and then you plug the given slope and your new y-intercept back in. If you just find the y-intercept, that's not what we're looking for. We're looking for the equation of the line, and typically it's in y equals mx plus b form. Now, I have to remember, I also, if I have a slope of -2 and I go through the point 1, 3, have another equation that we can use. And this is where some of us are not used to this particular equation, but it is your point slope formula, and Miss Little has informed me that she uses it a lot in calculus. So if you are moving into the calculus realm, and anywhere in college, they may expect you to know this as well. It is actually y minus y1 is equal to your slope times x minus x1. Now, the way we use this particular formula is the y and the x, they just stay exactly as they are. We don't do anything to the y and the x. What we do is plug in, this is going to be my y1, so we're going to plug in our 3 right here. Obviously, our slope isn't going to be hard to determine. We're going to plug our slope in right here, and then our x is actually going to be our x1 up here. So we're going to pull that from here. So the y and the x stay exactly the same. I plug in my 3 from up here, so it's y minus 3. I plug in my -2 times x minus 1. Once you plug into this particular formula, then you have to clean it up. It depends on you which order, but I'm a distributive property girl. I'm going to do that first. So I get y minus 3 equals -2x plus 2, because a negative times a negative is a positive. And then I'm going to add my 3 to both sides, so that we get y equals -2x plus 5. So as you can see, y equals -2x plus 5, y equals -2x plus 5. Same answer, just a different formula. I'm going to write that formula again one more time for some of us who have not seen it or haven't used it a lot. It's y minus y1 equals the slope times x minus x1. This is called the slope point formula. Now, I know there are a few of you like me who like to know where on earth this came from. If you think about your slope being equal to y2 minus y1 over x2 minus x1, if you were to take this denominator and multiply both sides by x2 minus x1 and this side by x2 minus x1, is that looking familiar? That's going to isolate your y2 minus y1, and it's going to leave you with slope times x2 minus x1. So that's exactly where that formula comes from. All of us should know that the slope is equal to y2 minus y1 over x2 minus x1. And that's actually what we're going to have to use for the next formula. The next type of equation, or pardon me, the next type of problem that we're going to have is if I give you 2 points and you have to write the equation in the line when you are given 2 points. So, if I give you -3, 3, and then 3, -1, how can we write the equation of this particular line? Well, this time we don't have the slope or the y-intercept. So we go to our slope formula. That slope is equal to y2 minus y1 over x2 minus x1. I have my x1, y1, and I have my x2, y2. So when I plug in to find my slope, I'm going to have -1 minus my y1, which is 3. And all of that is going to be divided by my x2, which is 3, minus my x1, which is, oops, I messed my colors up. I'm sure someone noticed. I'm going to subtract, and then I'm going to use my green to represent my -3. So that is actually going to give me a slope of -4 over 3 minus -3. That adds, and so we're going to get 6. So my slopes can simplify to -2/3. Now that I know my slope, I need a y-intercept. It's up to you which one of your formulas you want to use. If you want to just plug into y equals mx plus b, you can use either of those equations. So you have either point. I'm going to go with neither of them. They both have a negative, so we are going to have 3. I'll choose this one. 3 equals my slope of -2/3 times my y of 3 plus b. And just so you know where those come from, this is my, oops, I messed up again. I'm fired. That's -3. So I plug in my 3 from up here, that's where it came from, and my -3 here, that's where we come from. To clean this up a little bit, I'm going to have 3 equals -2/3 times 3. My 3's cancel. Negative times a negative gives me a +2 plus b. And then I subtract 2 from both sides. So 1 equals b. This gives me a slope of -2/3, a y-intercept of 1. So y equals -2/3 x plus 1. I'm probably going to have to do another video because we need to talk about parallel and perpendicular lines real fast. But just to make sure we're good on that last equation, y minus y1 equals m times x minus x. Ooh, sorry, it's late. My brain's not working. So we have y minus our y1, which was 3, equals -2/3 times x minus my x1, which is -3. Minus a negative gives me a positive, and so I'm going to have y minus 3 equals -2/3 x when I distribute, and then negative times a positive gives me -2. When I add my 3 to both sides, then I get y equals -2/3 x plus 1. Same equation. So we're good. I only have a minute left, so I'm not sure that I'm going to be able to fit this in, but we do have to understand parallel and perpendicular lines. If you have a slope, then we have a parallel slope. Well, slope and perpendicular. So if my slope is 2, remember your parallel slope is exactly the same, so it is 2, and my perpendicular is the opposite reciprocal, so that's -1/2. This is 2 over 1, so the reciprocal is 1 over 2. If we have 1/3, 1/3 is parallel, negative 3